Hi everyone, this is Denise and this is my final presentation. So today I'll be walking everyone through this pathway that we've spent the last several weeks learning about and putting together to show how glucose and CO2 can lead to the production of ATP as well as nucleotide synthesis for DNA replication. So to start, we'll go over here. Sorry if this ruins anything. So glucose is broken down during glycolysis to form pyruvate, which is down there, which then enters the pyruvate dehydrogenase complex down here, and then will form acetyl-CoA. NADH and CO2 are also produced at this time, where CO2 will play a role later on that I will discuss, and NADH and acetyl-CoA play an important role in ATP synthesis. Then they enter the citric acid cycle, where more NADH and CO2 are made along with ATP and FADH2. Okay, then NADH and FADH then enter the electron transport chain, which produces a hydrogen gradient that will use NADH and FADH to produce more ATP. Okay, now back to glucose. Over here, glucose 6-phosphate is produced, which is right over here. And this will go into the pentose phosphate pathway where, give me 1 second, where ribose, over here, where ribose 5-phosphate is made and is the key component to the PRPP. PRPP is the starting point of the pathway that will lead to purine synthesis. Which, give me 1 second, let me just find that. 1 second, just bear with me. Okay, yeah, over here. So, and we end with inosinate, and we're going through over here 2 different pathways right here. Sorry, excuse my band-aid. Okay, and then we end up with adenine and guanine. Okay, so as mentioned earlier, CO2, which is up there, will play a role, which it's here. Uridylate, which is right up here, is produced, which is the start to the pathway to the development over here. If you see it here, it develops UTP, CTP, and TTP, and this is how glucose leads into the ATP production and also leads into nucleotide synthesis, because these are purines along with adenine and guanine that is formed for DNA. Thank you.